Alright, ladies and gentlemen, so these are the answers and the problems from your quiz over your summer work. I'm going to work these out for you, show you how to do them. So here's problem number 1. It was 5 times 10 to the negative 8 times 2.9 times 10 to the 2. First, we need to take the 5 and the 2.9 and we'll multiply those together. So 5 times 2.9 gives me 14.5. Now these numbers that are 10 times 10 raised to the negative 8 and 10 raised to the 2, I need to multiply those together. And we use the law of exponents, so negative 8 plus 2 gives me a negative 6. Then I put these together, so 14.5 times 10 to the negative 6. I accepted this for full credit, but you could have gone another step further, put it in scientific notation. That'd be 1.45 times 10 to the negative 5. Okay, here's problem number 2. 2.998 times 10 to the 8 meters per second is how many kilometers per hour? So I'm going to set this up like a unit conversion problem. So I start off with what I'm given. 2.998 times 10 to the 8th meters per second, sure to include my units. Now I know there are 1,000 meters in 1 kilometer, and I need to put meters on bottom so that it will cancel with the meters I had to start with. Okay. I also know there's 3,600 seconds in 1 hour, so there's 60 seconds in a minute, 60 minutes in an hour, 60 times 60 is 3,600. I need the 3,600 seconds on top though so that it cancels with the seconds on bottom that I had to start with. Meters and meters cancel, seconds and seconds cancel, and what I've got left here is kilometers per hour. Now I can simplify this a little bit, right? So I'm taking this number, the number I had to start with, multiplying it by 3,600 and dividing it by 1,000. Well, 3,600 divided by 1,000 is really just 3.6. So really I'm taking this number I started with and then multiplying it by 3.6. And that'll give me the number of kilometers per hour. If you'd stopped here, you'd written anything along these lines, I would have given you full credit for it. If you did go ahead and multiply it out, you would have gotten 1.1 times 10 to the 9th kilometers per hour. Here's question 3. Find A if given C and theta. So A is over here. A is the opposite side, right? Here's the angle theta. A is all the way across the triangle from it. That's the opposite side. And C is the hypotenuse. Okay, so I'm going to look at SOHCAHTOA. That'll tell me if I need sine, cosine, or tangent. And in this case, I'm looking at the opposite side and the hypotenuse. Opposite and hypotenuse go along with the sine function. So sine theta equals A over C, where A is the opposite and C is the hypotenuse. Now I'm going to multiply both sides by C. On the right-hand side, my C's cancel. On the left-hand side, there's nothing to cancel with, right? It's just C times sine theta. So that's my answer. A is going to be equal to C times sine theta. All right, problem 4. Find theta if given B and C. Well, B is the adjacent side, and C is still the hypotenuse. So I look at SOHCAHTOA again. Now I'm dealing with the adjacent side and the hypotenuse. So this is going to be my cosine function. Cosine of theta is the adjacent side over the hypotenuse. Now I'm solving for theta, right? So what I'm going to do is I'm going to do the cosine inverse function to both sides of the equation. Whatever you do to one side, you have to do to the other. Cosine inverse times cosine of sine cancel. That line goes a little bit over the theta. It shouldn't. I'm just trying to cancel out cosine to the negative 1 and cosine. Theta is still there. It's not canceled out. Whatever I do to one side, I have to do to the other. So I have cosine inverse B over C. That's my final answer. Okay, so the cosine inverse undoes the cosine function and leaves me with just theta. Okay, here's question number 5. Solve for t if A equals V over t. So the first thing I'm going to do is I'm going to multiply both sides by t. Notice that when I started off here, I had t in the denominator. I had it in the bottom of the fraction. Ultimately, to solve for t, I want t in the numerator. I want it on top, and I want it by itself. So I'm going to multiply both sides by t to start off with, and the t's will cancel on the right-hand side. I've got a t on bottom, multiplying by t, those two will cancel. So I've got t times a equals v, right? Well, now I need to get rid of the a. Like I said, I wanted t in the numerator, but I also want it by itself. So if t is being multiplied by a, I'm going to divide by a. I'm going to divide both of those sides by a. And the a's cancel out on the left, and I'm left with t equals v over a. Okay, here's problem number 6. Solve for vi if vf squared equals vi squared plus 2ad. So if I'm looking for vi, I need to get it by itself equal to something else. Well, vi squared is being added to 2ad. So my first step is going to be to subtract 2ad. Whatever I do to one side, I have to do to the other. What that does, on the right-hand side, those two ADs cancel. Plus 2AD, minus 2AD, those two things go away. So now I've got vi squared equals vf squared minus 2ad. Square roots will undo a square. So I want to square root both sides. Okay, if I square root the left-hand side, the vi squared and the square root will cancel, but then I have to square root the entire other side. I saw lots of quizzes where we square rooted it and maybe we square rooted one term but not the other, or did something weird along those lines. You have to square root the whole thing. On the left-hand side, the square and the square root will cancel. On the right-hand side, I still have vf squared and it's still under the square root. I can't separate it because there's a subtraction sign between these two. These are two separate terms, and I can't just square root the vf and kind of pull it out of that term there by itself, right? So I've got to square root the whole thing. I'm just going to leave it that way, and that's going to be the answer for number 6. Okay, on number 7, solve for g. So t equals 2 pi square roots L over g. My first step is going to be divide by 2 pi. Okay, so that's going to cancel out this 2 pi over here. Ultimately, again, I'm looking for g to be in the numerator and also by itself. So I'm going to divide by 2 pi. What that does on the right-hand side, those two cancel. On the left-hand side, I've got t divided by 2 pi. Now I'm going to square both sides, right? I've got L over g under the square root. So by squaring that side, that's going to undo the square root. But whatever I do to one side, I have to do to the other, so I have to square this entire side over here. When I square a fraction, I need to square the top and the bottom. So t times t is t squared. 2 pi times 2 pi gives me 4 pi squared. 2 times 2 is 4. Pi times pi is pi squared. And then on the right-hand side, those canceled and went away. Now, I could do this in about 3 or 4 more steps to get this done, or I could do it quickly in one step. I'm going to show you the quick way to do this. If I have a fraction equal to a fraction, I am allowed to move things diagonally. Okay, this just comes from cross multiplication. I can multiply on one side, divide by the other, and then move things ultimately diagonally. So I'm going to move the g up here on top, and I'm going to move the t squared down there on the bottom. Okay, I'm also going to take this 4 pi squared, I'm going to move him up diagonally that way. So that when I'm done, I want to put g by itself in the numerator, right? This g came from down here up to the other side. So I have g by itself in the numerator. I have my t squared down here on bottom. And then I move the 4 pi squared up to the L. So 4 pi squared L over t squared. So whenever you have a fraction equal to a fraction, we can move things diagonally like that. Okay, here's question number 8. Sketch the relationship y equals mx plus b, where m is less than 0 and b is greater than 0. So y equals mx plus b is just the equation of a line. So we're looking for a line on your graph. Now, m less than 0. Well, if something's less than 0, that makes it negative. So m being negative just means I have a negative slope. So the line that you draw needs to have a negative slope. And then b being greater than 0 just means that my y-intercept is positive. Any graph that looked like this would have done. My y-intercept needed to be positive, needed to be up here above the x-axis somewhere. And then my slope needed to be negative, so it needed to run down to the right. Okay, any graph like that would have satisfied that question. Here's number 9. Sketch the relationship y equals 1 over x. This is an inverse relationship, so as x gets larger, the overall fraction here gets smaller. Right? 1/2 is smaller than 1 over 1. 1/3 is even smaller than 1/2, right? And so on. So as x gets larger, y gets smaller. It looks like this. Right? This is it. So we start off, if x is very, very small but it's positive, I have a very, very large y. As x gets larger and larger and larger, y gets smaller and smaller and smaller. Now if we use negative values for x, it just looks like this. It's just flipped over into the third quadrant. Okay, here's number 10, right? So t equals 2 pi square roots L over g, and t equals 1 over f. Solve for L in terms of pi, g, and f. So ultimately what I want here is I want L equals something, and that something it equals to is only allowed to have pi, g, and f. Okay, let me look at this first equation here real quick. L is what I'm solving for, so L is up here. That's okay. I'm going to use L because L, ultimately I want to say L equals something. G is okay too, right? Because G, it's one of the terms that I'm allowed to have L solved as a term of, right? So L and G are okay. But if I come over here, I've got capital T. T is not one of the terms that I'm allowed to solve for L. Okay, so somehow I need to get rid of T. Well, hey, over here I have this other equation that says T equals 1 over F. And f is one of my allowed terms. So I'm just going to set those two things together, right? I'm going to combine these equations together so that t disappears, and then I'm going to solve for L. Here's the first step, right? 2 pi square root L over G has to equal, here's the second equation, 1 over F. If this is equal to T, and if this is equal to T, they must be equal to each other. Okay, so I'm just going to set them equal. At this point, do a little bit of algebra, right? I want to get rid of this 2 pi that's over here. So I can either divide by 2 pi or I can multiply by 1 over 2 pi, right? Multiplying by the reciprocal is the same as dividing. Either way, those 2 pi's cancel, and whatever I do to one side, I do to the other. So I've got 1 over 2 pi over here on the right-hand side. I just rewrote that. So this is the square root of L over G equals 1 over 2 pi F. Right? When I multiply fractions together, I multiply the top together, multiply the bottom together, write it as a fraction. There it goes. Now to get rid of the square root sign, I'm going to square both sides. When I square the left, the square root sign goes away. When I square the right, again, I have to square both the top and the bottom. 1 squared on top is still just 1. 2 pi F is going to give me 4 pi squared F squared. 2 times 2 is 4. Pi times pi is pi squared. F times F is F squared. So it's going to give me that. Now I want L in terms of this other stuff, right? So I need to get rid of the G. G is on bottom, so essentially I'm going to move it diagonally up there to the top, or you could think about that as being like multiplying both sides by G. And this is going to be your final answer here. L equals G over 4 pi squared F squared. And that's it. So hopefully you did well on that quiz. If you need to retake it, please come in and see me. Let's talk about it, study, look over your quiz, fix anything you did wrong, and if you have any questions, come see me. Thanks.